Osborne from SUNY College of Environmental Science and Forestry in Syracuse, and I was curious how many times gastropods, that's slugs, snails, and limpets, have transitioned between major habitat types. So just about every animal phylum began in the ocean, but several animal groups have subsequently invaded freshwater and terrestrial biomes, and the fact that they have done so as many times as they have is frankly kind of astounding to me because of the dramatic physiological and even developmental changes that go along with these habitat transitions. So moving into freshwater, animals have to osmoregulate in a hypotonic environment. Moving on land, they have to breathe in a different medium, resist desiccation, and generally transition from a planktonic larval life stage to direct development. Additionally, to get to the terrestrial and freshwater biomes, organisms generally have to pass through the intertidal or estuarine, that's marine freshwater interface. And these habitats present their own challenges. For example, dramatic fluctuations in salinity and temperature and intermittent exposure to air. Additionally, there have been animals that have transitioned back to a fully marine lifestyle. And to give you an idea of how often that can occur, I want to give a shout out to Liz Miller, who will be giving a talk in this room later this morning on amniotes moving into the marine realm. And these are some numbers she provided on how many times she thinks that's happened. So quite a bit. So why should we care about major habitat transitions in gastropods specifically? Mollusks are the second most diverse animal phylum, and gastropods account for the overwhelming majority of these species. Additionally, we know that gastropods occur in marine, freshwater, and terrestrial ecosystems, but we don't have a good handle on how many times they've transitioned between these ecosystems. So there's some potentially very labile, ecologically labile groups within the gastropods that may be good model taxa for looking at other kinds of evolutionary changes that go along with major habitat transitions. So there are 5 subclasses within gastropods: the Patelogastropoda, Betigastropoda, Neridomorpha, Sanogastropoda, and Heterobranchia. Some of you may have seen these guys in your gardens. And for the remainder of the talk, I'll be using the color scheme you see here to indicate different major habitat types. So the Patelogastropoda are known for being intertidal, but there are some fully marine species. The Betigastropods are known for being marine, but some are intertidal. And the Neridomorpha, Sanogastropoda, and Heterobranchia are all found in multiple major habitat types. So, there have been previous attempts to quantify the number of habitat transitions within Gastropoda, perhaps most notably in Little's terrestrial invasion. He has an estimate of how many times gastropods have terrestrialized, but he was going off a now out-of-date taxonomy, so I'm not sure how reliable that estimate still is. More recently, Strong et al. Have estimated 33 to 38 transitions to the freshwater realm. Other research groups have focused on taxa within the gastropods and tried to count transitions just within those taxa. However, the level of detailed information about those transitions and habitats varies quite a bit from paper to paper. So on one end of the spectrum, we have papers like Dayrad et al. That don't show any habitat information on their phylogeny, but do discuss the implications of their phylogenetic reconstruction for understanding habitat transitions in the panpulmonates. And from their phylogeny, it looks like there's been 2 terrestrializations, 3 transitions to freshwater within the panpulmonates. Next, we have papers that indicate the habitats of extant taxa on their phylogenies. This is papers like Kamato and Kano, who looked at the Pometiopsids, which are primarily freshwater group, and they found 3 terrestrializations, 1 transition to intertidal. And then we also have Criscione and Ponder, who looked at a subset of Sanogastropod families, and based on their phylogeny, it looks like there's been 1 terrestrialization, 1 transition to freshwater, anywhere from 3 to 8 transitions to brackish, and 1 to 5 transitions back to marine within their subset of families. And finally, we have papers that either infer or reconstruct ancestral habitat types under the phylogenies. So that's Cano et al., who looked at a group of sea slugs and found 1 terrestrialization, 1 transition to freshwater, and 2 transitions to a brackish environment. And this paper here that looks at the neuridids and finds 4 transitions to freshwater, 1 to brackish, and 1 to marine, and or 1 back to marine, I should say, within a marine group. However, there are currently no gastropod phylogenies for the whole class that have the taxonomic detail or even habitat information necessary to perform these kinds of analyses for the whole class. So with an eye to that problem, we reviewed current phylogenies from across the gastropod tree and tried to piece these together to infer where some of these major habitat transitions have occurred. We can also use these analyses to figure out which of these groups we really need to get down to maybe the species level to see all the habitat transitions, and which one we can simply place at a superfamily or even order level within the class to capture those transitions, and which groups might benefit from more detailed habitat, ecological, or life history data to understand how these transitions are happening. So basically, we scour the literature to determine the major habitat types found in most of the gastropod families. I then used the taxonomy and Brusca et al. As a guide to literally cut and paste together different gastropod phylogenies, and then combined that habitat and phylogenetic data to guesstimate where these habitat transitions may have occurred in the phylogeny. So some important caveats here. Often you'll see intertidal taxa referred to as marine in the literature, or estuarine taxa referred to as intertidal. So depending on the nature of the incomplete information, I may be overestimating or underestimating transitions between these particular habitats. So beginning with the Gastropoda, not surprisingly, it looks like we have several intertidal taxa, a few transitions to fully marine. There is some disagreement as to the phylogenetic relationships within Gastropoda. If we go with a different phylogenetic hypothesis, we get a slightly different pattern of habitat transitions. And I've redrawn the phylogenies so that they're easier for me to see, and also so I can kind of trace back what habitat I think was there along the branches. Some of them I didn't feel comfortable making a hypothesis about the ancestral habitat. Basically, I just kind of squinted at this and used some basic parsimony logic. So I've left those branches gray. You can see that with Nacella and Solana in the first phylogeny. We also notice that Nacella includes both fully marine and intertidal representatives. So depending on which phylogeny we prefer, we get anywhere from 0 to 3 transitions to an intertidal lifestyle, and 1 to 2 to fully marine. Interestingly, Gastropoda seems to be ancestrally intertidal, which is pretty unique among gastropods, which are believed to be ancestrally fully marine. So I have marked Gastropoda as yellow or intertidal for the remainder of the talk. Gastropoda, not a lot of surprises there. We've got a lot of marine and a few freshwater taxa. Intertidal taxa. And we do have 3 taxa with both intertidal and fully marine representatives. I particularly like to point out turbidity that has, I believe, 1 intertidal genus. It looks like we've got 4 to 5 transitions to the intertidal and 0 to 3 transitions back to fully marine. The Neuridomorpha start to get a little more complicated, and again, there's some disagreement as to the relationships between major lineages within the Neuridomorpha. If we, just pick a phylogeny and go, it looks like we've got 2 to 3 terrestrializations, 6 transitions to freshwater, 1 transition to an estuarine lifestyle, and that's within that predominantly freshwater group, and 1 to 3 transitions back to fully marine. If we pick a competing phylogenetic hypothesis, it switches the position of these 2 branches, which luckily for us doesn't change the number of estimated habitat transitions. Gastropoda get a lot more phylogenetically complex and have quite a few more habitat transitions. So we've got 8 terrestrializations, 5 transitions to the intertidal, anywhere from 10 to 12 transitions to freshwater, 3 to 5 to estuarine, and 6 to 8 transitions back to the marine realm. Heterobranchia are similarly phylogenetically complicated and also have quite a few transitions. We've got 6 to 8 transitions to terrestriality, 7 to intertidal, 6 to freshwater and to estuarine, and 3 back to fully marine. So how does this look across the whole class? Based on these analyses, I estimate anywhere from 75 to 93 major habitat transitions within Gastropoda. However, I believe this to be an underestimate, in part because if you look at Nacella, I'm only counting that as one transition when that may be, there may be several transitions just within that, that genus, for example. I was somewhat surprised at the relative lack of transitions from freshwater to terrestriality and vice versa. We also see that Patelogastropoda seems to be ancestrally intertidal, and that Cenogastropoda and Heterobranchia are particularly prone to major habitat transitions. Counting up the number of transitions within the class as a whole, it looks like we've got 16 to 18 independent terrestrialization events, 10 to 12 transitions to freshwater, and 11 to 19 back to marine. If I treat intertidal, estuarine, and marine as synonyms, that number drops to 6 to 13 transitions to marine. So these analyses can really show us which parts of the phylogeny can really benefit from increased phylogenetic detail and increased habitat information. There have been several attempts in the past decade to reconstruct class-level phylogenies for Gastropoda. However, none of these have had the taxonomic resolution necessary to really do these kind of analyses. And we also find from these analyses groups that are particularly prone to major habitat transitions, which we can use as model systems to look at other evolutionary changes that go along with major habitat transitions, potentially changing rates of molecular evolution and positive selection, changing osmoregulatory strategies, loss of a planktonic belt or larval stage and transition to direct development, and transitioning between gills and lungs. So I think the future of this kind of research is really to reconstruct a class-level phylogeny for Gastropoda, and some parts of that phylogeny really going down to the species level to capture all of these transitions. Finally, I'd like to give a shout out to the other members of the Gastropod Terrestrialization Research Group in the Rendell Lab, particularly Tim and Alyssa, who just finished their undergrad degrees and are presenting posters here at Evolution this week, and Jesse, who usually doesn't look like that, who's giving a talk tomorrow afternoon. And I am happy to take any questions. Yeah.
So gastropods and bivalves aren't really directly comparable, so this might be a bad question, but do you have any sense of how many transitions in habitat were sort of in that group?
No, I don't know how many in bivalves. There are no terrestrial bivalves. Just about most bivalves are filter feeders, so they can't really make it outside the water. There are definitely freshwater lineages, but I don't know how many. And I don't know how many of move back to the marine either.